Okay, we're ready for day 3. And today we're just going to talk about 2. We're going to first talk about this function, which when we study it as a conic is called a parabola. But its most practical name, even if not used a lot other than by math teachers, is the reciprocal function. Why? Because its equation tells you that y is the reciprocal of x, because it's 1 over x, and we know 1 over means reciprocal, because 2, 1 over 2, 3, 1 over 3. So we have our reciprocal function. Now what happens here? Our domain in this case is x can't be 0, or you could say, oh, I go from negative infinity to 0, union 0 to positive infinity. And my range, y cannot be 0, that is f of x. Or I could do the same thing over here and write it in interval notation. Now what's special about these is that the vertical asymptote is indeed x equals 0, and the horizontal asymptote is indeed y equals 0. And so I asked about what's happening. Well, this function is decreasing all of the time except at 0. That means it decreases here everywhere but 0. How else do we let you write this if we don't say interval notation? We just let you write x not equal to 0. Now, we want to talk about the end behavior. And the end behavior is where this is nice. As I'm approaching, notice I don't want to know what's happening in the middle, just what's happening over here. I see that the function is rising or increasing, is that it rises slowly from below, and it's going to be approaching the x-axis, or you could say the line y equals 0 if you chose. What happens on the right side? It's going to fall, the graph falls slowly from above now, and of course it's approaching the x-axis. Now, you could always say y equals 0. Very convenient for that one. Now, the last one we're going to talk about today is the greatest integer function. Now, the greatest integer function, when we're talking about greatest integer in this special case, is also called the step function because it looks like a bunch of little staircases going up. A bunch of steps going up, forming a staircase. And we write it with the double bar as I've shown here. What's the domain? It's the reals, that is negative infinity to positive infinity. What is the range? The range is the set of integers, or you could use the little ellipses and put 3 positives, 3 negative integers, and write it in that notation. That would be fine also. What do we know? This function is increasing over the reals, or we can just say it's increasing on this interval. What happens as x approaches negative infinity? It's decreasing. Notice as x moves this way, I'm heading down, so it's going to fall without bound, not quickly, not slowly, just at a regular pace. And as x approaches positive infinity, what's it going to do on this side? It's heading up. So x is rising without bound, or rises without bound. I should say falls here. And so that's all that we're doing for this one.